Hello dear students, welcome to maths class. Today we are going to start our new lesson trigonometry. Trigonometry, two words. Trigno means triangle and metry means measures. That means trigonometry is the measures of a triangle. What type of triangles in trigonometry? We are discussing about the measures of some right triangles. What do you mean by a right triangle? In a triangle, if one angle is 90 degree, it is called a right triangle. Here you can see a right triangle. What is special about this right triangle? See, here one angle is 90 degree. And what about the other two angles? They are 45, 45. Okay, so two angles are equal here. Then what it is an isosceles triangle, right? So in an isosceles triangle, what are the specialities of an isosceles triangle? This angle is equal to 45 degree and this one is also equal to 45 degree. If two angles are equal, it is called an isosceles triangle, but it is also a right triangle. Therefore we can say this triangle, that is an isosceles triangle with one angle 90 degree, is called isosceles right triangle. Okay, isosceles right triangle, that is our name. What is the name? Isosceles right triangle. Okay, so this one is an isosceles right triangle. So in an isosceles right triangle, what are the other two angles? One angle is 90 degree, we know that. Then the other two angles are 45, 45 each. Now we are going to find out the relation between the sides of an isosceles right triangle. Let us do that. See, here you can see a right triangle. Okay, one angle is 90 degree. What about the other two angles? Let us measure these angles. Okay, one angle is 45 degree. Then what about the other angle? Yes, that angle is also equal to 45 degree. Then what about the third angle? Yes, it's obviously a right triangle. So this is a right triangle with the, yes, two perpendicular sides. What about the length of the perpendicular sides? Yes, here you can see the length, one perpendicular side is 1 centimeter. Then the other side is also equal to 1 centimeter. Then what about the, see, this one is 1 and this one is also equal to 1. Then this is a right triangle. In a right triangle, we know that, yes, we can use the Pythagoras Theorem. What is Pythagoras Theorem? Base square plus altitude square is equal to hypotenuse square. Here what is the base and what is the hypotenuse and what is the altitude? See, 1 centimeter is base, 1 centimeter is height, and what about the hypotenuse? Let us find out the hypotenuse. See, this is, yes, 1 square plus 1 square. Yes, what is equal to 1 square plus 1 square? 1 square is 1 and 1 square is 1. So 1 plus 1, that is equal to 2. Okay, that is the hypotenuse square is equal to 2. Then what is hypotenuse? Yes, hypotenuse is equal to root 2. That means this length is equal to, yes, this is equal to root 2. Okay, base and altitude are 1, then the hypotenuse is equal to root 2. Okay, now I am going to draw another right triangle with the sides 2 centimeter. Okay, let us draw another right triangle with the sides 2 centimeter. Okay. See, this one is a right triangle with the sides 2 centimeter. That means the base and altitude 2 centimeter. Okay, this one is equal to 2 and this equal to 2. Then what about its hypotenuse? Base is equal to 2, altitude is equal to 2. Then what about its hypotenuse? That is this FH, that is equal to, yes, root of 2 square plus 2 square, right? Base square plus altitude square, and its sum of base square plus altitude square and take its root, then we get the hypotenuse. Okay, so root of 2 square plus 2 square. What is 2 square? So 2 square is equal to 4 plus 2 square is equal to 4. Okay, so root of 4 plus 4 is equal to, yes, root 8. Okay, root 8. Then root 8, how do we simplify this root 8? Yes, we know that root 8 is, yes, root of 4 into 2, right? Root of 4 into 2. And root of 4 is 2, right? And we don't know the root of 2 and we write it as root 2. So that is equal to 2 root 2. Okay, so the hypotenuse is equal to 2 root 2. Okay, hypotenuse is equal to 2 root 2. So here, yes, if sides are 1 and 1, then the hypotenuse is equal to root 2. Then the sides are 2 and 2, then the hypotenuse is 2 root 2. Okay, now I am going to draw a triangle with the sides 3 and 3. Okay, that is the base and altitude 3 and 3. Then what will be the hypotenuse? Let us find out the hypotenuse. Okay, so altitude 3, base 3. Okay, so this one is also a right triangle with the two angles are 45 degree. That means this one is also an isosceles right triangle with the base and altitude 3 centimeters. Okay, so here we have, yes, this side is equal to 3 centimeter. This one is also equal to 3 centimeter. Then what about the hypotenuse of this triangle? That is equal to, yes, root of 3 square plus 3 square, right? Root of 3 square plus 3 square. Then what is 3 square? 3 square is equal to 9 plus 3 square is equal to 9. Okay, so that is equal to root 9 plus 9 is equal to 18. Okay, and we know that this 18 is actually, yes, 18 is actually 9 into 2. 18 is actually 9 into 2. And we know that 9 is a perfect square. And what is its square root? Its square root is equal to 3. Then root 2. So we can write it as 3 root 2. We can write root 18 as 3 root 2. That means here the, see, here the hypotenuse is equal to, here the hypotenuse is equal to 3 root 2. Okay, so can you find out the relation between the sides of an isosceles right triangle? See, what is special about the sides of an isosceles right triangle? If sides are 1, 1, then the hypotenuse is root 2. If base and altitude are 2 and 2, then the hypotenuse is 2 root 2. And if base and altitude are 3 and 3, then the hypotenuse is equal to 3, then the hypotenuse is equal to 3 root 2. Now I am going to find out the ratio between the sides of isosceles right triangle. For the first one, what is the ratio of the sides? Yes, here the first triangle, the ratio is 1 is to root 2. Okay, 1 is to root 2. So in the first triangle, the ratio of the sides is equal to 1 is to root 2. Okay, then in the second triangle, the ratio, what is the ratio? That is 2 is to 2 is to, yes, 2 root 2. Okay, but we are always written ratios in the simplest form, right? Ratios are always written in the simplest form. So here we have 2 is to 2 is to 2 root 2, right? So which number is common here? 2 is common here. So let us remove that common 2 from all the 3 terms. Okay, so 2 is, yes, it is actually 2 into 1, right? This is 2 into 1. This one is also equal to 2 into 1. And this is equal to 2 into root 2, right? So let us cancel the common 2 from all the 3 terms. Okay, so cancel it. Then we have the ratios equal to, or the simplest form of the ratio is equal to 1 is to 1 is to root 2. Okay, then what about the third one? Here also the sides are 3 root 2. So find out the ratio of the sides. Ratio is equal to 3 is to 3 root 2, right? 3 is to 3 is to 3 root 2. Here also we can see this 3 is a common number. Okay, so let us remove the common factor. Then we have the ratio 1 is to root 2. So this is a new relation. That is, in a triangle with angles 45, 45, 90, then their sides are in the ratio 1 is to root 2. Okay, whatever the sides, their sides are always in the ratio 1 is to root 2. This is applicable only for isosceles right triangle. Okay, in an isosceles right triangle, the sides are always in the ratio 1 is to root 2. So here we have the result, that is the sides of any triangle. Yes, this is our result. See, the sides of any triangle of angles 45, 45, 90 are in the ratio 1 is to root 2. Okay, so this is an important ratio, that is, in any triangle with angles 45, 45, 90 are in the sides are in the ratio 1 is to root 2. Okay, we cannot break this ratio. If the angles are 45, 45, 90, then the sides should be in the ratio 1 is to root 2. See, here you can see a triangle. What type of a triangle it is? Let us measure the sides of the triangle. See, next you can see a triangle here. What type of a triangle it is? It is an equilateral triangle. See, all the sides are equal here. All the sides are 2, 2 and 2. Okay, all the 3 sides are equal here. Then what about its angles? Yes, all the 3 angles are also equal. In an equilateral triangle, if all sides are equal, all angles are also equal. What about each angle? Yes, all angles are 60 degree. Okay, all angles are 60 degree. So this angle is equal to 60. Similarly, all the other angles are equal to 60 degree. Okay, so every angle is equal to 60 degree and every sides are equal. That is special about an equilateral triangle. And here you can see a perpendicular from the third vertex to the base. Okay, this is the third vertex and here this is the base. This line is a perpendicular drawn from the third vertex to the base. That perpendicular bisects the base. Okay, see here the total length of the side of the triangle is equal to 2 cm. And if this line bisects that line, what about this length? Yes, that is half of this 2 cm, which is equal to 1 cm. Okay, half of 2 is equal to 1 cm. Okay, and what about this side? This is equal to 2 cm. And we know that this line is perpendicular to the base. Perpendicular means the angle between the line is equal to 90 degree. Okay, angle between the line is equal to 90 degree. And we know that all angles are equal here. All angles are equal here, right? All angles are equal. All angles are 90 degree, right? So this angle is equal to, yes, 60 degree. And here, what about this one? That angle is equal to 90 degree. And then one angle is equal to 60, second angle is equal to 90, third angle. What about the third angle? See, in a right triangle, if we consider this one, this is a right triangle, isn't it? This triangle is a right triangle. Which triangle? Yes, this part only is a right triangle. And in that right triangle, one angle is equal to 90, second angle is equal to 60. Then what will be the third angle? We know that in a right triangle, one angle is equal to 90. Then sum of the other two angles, sum of this angle and this angle is also equal to 90 degree. Right? So, if this angle is equal to 60, what about this angle? Yes, that angle is equal to, yes, 30 degree. Okay, so here we got a 30, 60, 90 triangle. Okay, 30, 60, 90 triangle. Now, as we did in the isosceles right triangle, we are going to find out the ratio of sides of a triangle with angles 30, 60, 90. Okay, here, see, okay, this angle is equal to, yes, this angle is equal to 60, this one is equal to 90, and the third angle is equal to 30. Okay, so say 30, 60, 90 triangle. And what about the hypotenuse of this right triangle? Consider this part only. Okay, we need this part only, so consider that part only. Okay, this triangle only. And that triangle, the hypotenuse is equal to 2. Okay, hypotenuse is equal to 2. Then here the base of the right triangle is equal to, this part is equal to 1. Okay, then what about the altitude? Yes, since this one is a right triangle, we can use the Pythagoras theorem here. Okay, what is Pythagoras theorem? Pythagoras theorem is equal to base square plus altitude square is equal to hypotenuse square. And in reverse, yes, hypotenuse square minus base square is equal to altitude square. Here we need to find out this altitude. Okay, altitude. What is the altitude? Altitude is equal to, yes, root of base square minus hypotenuse square minus base square. What is hypotenuse square here? That is equal to 2 square minus, what is base here? Base is equal to 1. That is 1 square. Okay, base is equal to 1 square. Then let us write that is 1 square. Okay, what is 2 square? 2 square is equal to 4. Right? And 1 square is equal to 1. So here we have root of, yes, 4 minus 1 is equal to 3. Okay, so this side is equal to root 3. Okay, this side is equal to root 3. And if, yes, instead of this 2, instead of this 2, the sides of the triangle is 4. Instead of this side 2, if we have the side is equal to 4, then what about this side? This is equal to 2 centimeter, right? Then what will be this side? Yes, this side is equal to, yes, 2 root 3. Okay, this side is equal to 2 root 3. Okay, so if sides are 2 of a triangle or of a right triangle, then the 30, 60, 90 triangle having the sides 2, 4 and root 3. If sides of the equilateral triangle is 4, then the sides of the 30, 60, 90 triangle is equal to 2, 4 and root 3. And if it is, yes, if it is instead of this 4, if it is 6, then what will be this side? This side is equal to 3. Then this side is equal to, yes, 3 root 3. So this is also another result. That is, if the triangles having the angles 30, 60, 90, 30, 60, 90, then their sides are in the ratio to 1 is to root 3 is to 2. Okay, if the sides of a triangle are in the ratio 30, 60, 90, then 30, 60, 90, then if any triangles of angles 30, 60, 90, the sides are in the ratio 1 is to root 3 is to 2. Okay, 1 is to root 3 is to 2. This is our second result. We already know this result from 9th standard, right? That is, if in any triangle the angles are 30, 60, 90, the sides are in the ratio 1 is to root 3 is to 2. Okay, and the second one is, first one, we already know the result. The sides of any triangle of angles 45, 45, 90 are in the ratio 1 is to root 2. Okay, and here in any triangle the angles 30, 60, 90, the sides are in the ratio 1 is to root 3 is to 2. Okay, 1 is to root 3 is to 2. These are the two important ratio. So if we know any of the sides of these type of triangles, we can find out the other angles. Okay, that we will discuss in the later classes. So today I am going to wind up the class. Thank you children. Thank you.